Welcome to the video on the normal distribution. So first we'll learn about the normal distribution and curve. The normal distribution is a symmetric distribution around the mean, and it has a bell curve shape. So this is what our normal distribution looks like. For this distribution, your mean, median, and mode are the same. The distribution can be described by the mean and standard deviation. So your distribution of x is normally distributed with a mean of something and then your variance here, so your standard deviation squared. Your normal distribution occurs naturally in many situations. So height is typically normally distributed about the mean, as well as weight and several other things. So for your normal distribution, 68% of the data will be between one standard deviation plus or minus the mean. So mu plus or minus one standard deviation will have 68%. And then if you add two standard deviations, mu plus or minus two standard deviations, that'll have 95% of your data. And then if you go 3 standard deviations away from the mean, you'll have 99.7% of your data. So these are good numbers to remember. It's also called the empirical rule, the 68, 95, 99.7 rule. Now we'll learn how to find the normal probability with a calculator. So to find the probability that the outcome will be exactly equal to a number, you'll need to enter your number of interest, which is your x value, followed by your mean, which is mu, and then your standard deviation. And then you'll hit enter. The resulting value will be the probability that the outcome is equal to x. To find the probability that the outcome will be between two numbers, so if we look at our normal curve, and you have a mean of 10, and you wanted to find the probability of x being between 6 and 12, what you would do is you'd find the area under the curve using normal CDF. So you'll click second vars and scroll down to normal CDF. So it's CDF instead of PDF. You'll enter the lower limit. If you're just trying to find everything below 12, there wouldn't be a lower limit. So you would put negative infinity. You can't type negative infinity, so you would just put a really big negative number. So this is an example of that here. Then you would do your upper limit. In this case, we'd say 12. You'd have your mean and then your standard deviation, and then you'd hit enter. And the resulting value would be the area between the two limits. So it might give you 0.86, for example, which would mean 86% of the time your data will fall between those two numbers. Next, we have inverse normal calculations. So to do this, you would use the area or probability, the mean and standard deviation to work backwards and find an x value. On the test, when you're performing inverse normal calculations, the mean and standard deviation will be given. So to find this with a calculator, you would do second vars, which is distribution, and then scroll down to INVNORM, so inverse normal. You'll enter your area. So if I wanted to know what the 85th percentile was, or what the number is where 85% is below that. So your area is always going to be the area to the left of the number, and your standard deviation, and click enter. When you click enter, your screen will look like this, and that number there would be the number or the x value where that much area exists to the left. If you wanted to know the x value when the area to the left is 85%, the mean is 0, and the standard deviation is 1, then our 85th percentile, or number with 85% to the left, would be 1.036. So that's what you do for that. So here we have our first IB practice question where the calculator is allowed. It says the height of chimpanzees is normally distributed with a mean of 82 centimeters and a standard deviation of 4 centimeters. A, what's the probability that you select a random chimpanzee and the height is between 80 centimeters and 84 centimeters? So if we draw our normal curve, our mean is 82 centimeters. And we're looking for the probability the height is between 80 centimeters and 84 centimeters. So we're looking for this area here. And because we're looking for the area between, we're going to use normal CDF in our calculator, where our lower limit will be 80, our upper limit will be 84 centimeters, mu is 82 centimeters, and our standard deviation is 4 centimeters. So we'll go ahead and enter all of that into our calculator. And when you hit enter, you'll get a result of 0.383. So this means there's a probability of 0.383 that you would select the height between 80 centimeters and 84 centimeters. So it's a 38.3% chance. So 0.383, which is 38.3%. And with statistics, a lot of the time you want to answer in a full sentence. So you could say the probability is that. Just like that. And then it says, how tall is a chimpanzee if it's in the 20th percentile? So for this one, we're given a percentile. So we need to find where on our normal curve is there 20% below it. So we want this area to be 0.2. We're trying to find this x value when our mean is 82 centimeters and our standard deviation is 4 centimeters. So for this, we're going to use inverse normal, where the area is 0.2, mean is 82, and standard deviation is 4. So you can go ahead and enter that into your calculator, and that would give us an answer of 78.6. So if a chimpanzee is in the 20th percentile, it'll be 78.6 centimeters. So that's it for that question. Now for our second IB practice question, it says the weight in kilograms of newborn babies is given by the model. W is normally distributed with a mean of 3.4 and a standard deviation of 0.32. So your variance is 0.32 squared. It says find the probability a newborn weighs less than 2.6 kilograms. So we'll draw our normal curve. We have a mean of 3.4. And we want to know the probability that it's less than 2.6. So we're trying to find this area here. So we're going to find the area between negative infinity and 2.6. So we'll use our normal CDF with a lower limit of negative 9999999, as many nines as you want to put, an upper limit of 2.6, a mean of 3.4, and a standard deviation of 0.32. So you can enter that into your calculator, and that'll give you 0.0062. So the probability a newborn weighs less than 2.6 kilograms is 0.0062. which if you move the decimal over twice, you'll get 0.62%. So there's your answer to part A. Then part B says, 5 random newborns are selected. Find the probability that all of them have a weight greater than 3.5 kilograms. So to have a weight greater than 3.5 kilograms, so our mean is 3.4, 3.5 is here. We're trying to find the probability on this side, greater than. So we'll use our normal CDF, where the lower bound is 3.5, the upper bound is infinity, so 999999999. The mean is 3.4, and the standard deviation is 0.32. When we enter this into our calculator, we'll get 0.37733. So this is the probability that one newborn has a weight greater than that. To figure out that probability for 5 people, we can use our binomial distribution, because it either can weigh more than that or it cannot weigh more than that. So for our binomial distribution, the number we're looking for is 5 successes out of a total of 5 trials, where our probability of success is 0.37733, and our probability of failure is 1 minus 0.37733. So we'll have n choose x of p 0.37733 to the x times q, which is 1 minus 0.37733 to the n minus x. So 5 minus 5. So this is to the 0, so this just becomes 1. 5 choose 5 is also 1, so we just have 0.37733 to the 5th, which equals 0.00765. So the probability of all 5 weighing greater than 3.5 kilograms is 0.00765, which is 0.765%. So that's your solution to part B. So in summary, the normal curve is a symmetric distribution about the mean and has a bell curve shape. The mean, median, and mode are the same. The distribution can be described by the mean and standard deviation. It occurs naturally in many situations, such as height, weight, etc. A calculator can be used to find the probability the outcome will be exactly equal to one number and the probability of the outcome being between two numbers. The inverse normal curve uses the area or probability, mean, and standard deviation to work backwards and find an x value, and a calculator can be used to find the x value using the area. That's all for this video. Thank you for watching.